Have you ever wondered how we turn thoughts into words, or how a simple sound can carry so much meaning? Language is like a puzzle. Today we're going to break it down into its smallest pieces. By the end of this video, we will have made a case that the universe was spoken into existence, and that the language used to do so was numerically based. This video will be divided into two main sections. The first will give a description of the structure of language, and the second will show how this connects to my theory of a unified field. We begin with phonemes. These are the tiniest units of sound in a language that can change meaning. For now, we can think of them like the atoms of speech. This isn't the best analogy since there are things smaller than atoms, but it's close enough for now. For example, in English the word cat has three phonemes, ka, a, and t. Swap the ka for a ba, and you get a bat, a totally different word. That's the power of a phoneme. They don't mean anything on their own, but they're the foundation of everything we say. Every language has a set of phonemes. English has about 44 depending on accents. Some languages like Hawaiian have fewer, while others have over 100. It's these sound differences that make each language unique. Now let's zoom out a bit to morphemes. Morphemes are the smallest units of meaning in a language. If phonemes are like the atoms, morphemes are like molecules. They're built from phonemes, but carry an additional weight of meaning. Take the word unhappy. It's made of two morphemes, un, which means not, and happy, which we all know. Put them together, you've got a new idea. So phonemes make up morphemes, and morphemes make up words. But language doesn't stop there. Words team up to form syntax, the rules that govern how we arrange them into sentences. For example, the cat chased the mouse follows the syntax of the English language. Switch it to chase the mouse the cat, and it sounds like Yoda's talking. Syntax varies across languages. Some put verbs first, others put them last. It's like the grammar glue that holds our thoughts together. And then there's semantics, the study of meaning itself. It's how we know the cat chased the mouse means a feline hunt, not a cooking recipe. Semantics works within context, culture, and even tone to make sure we're on the same page. Finally, we've got pragmatics, the real-world use of language. It's why "can you pass the salt" isn't just a question about your ability, it's a polite request. Pragmatics is all about reading between the lines and determining the spirit of the conversation or the intention of a person. Let's recap. Phonemes give us sounds, morphemes give us meaning, syntax gives us structure, semantics gives us understanding, and pragmatics gives us connection. Together these building blocks turn a jumble of noises into the incredible tool we call language. So how does this connect to the structure of the universe? How can we possibly show that the universe was spoken into existence? The foundation for a mathematical language is a finite set made with numbers. In simple terms, we are looking for an alphabet or a group of phonemes, but this time we're not using letters, we're using numbers. Just like the language of this video, which is composed of 26 letters, we are looking for a mathematical equivalent using numbers. Numbers are like the fundamental particles of the universe, because they cannot be deconstructed into something simpler. And just as we might expect with an alphabet or a set of phonemes, we have a group of numbers describing these particles that are countable and finite. Using the numbers 1 through 9 plus the number 0, it is possible to construct this mathematical model, which I believe represents a unified field theory. This is my evidence is built using the universal language. Every number on screen is a complex number made using 1 through 9. We can say that 1 through 9 are the phonemes of this model. If we take a number and change it, we fundamentally alter it into something different. 1 is not 2, 2 is not 3, A does not equal B, and B does not equal C. Earlier in this video, we stated that phonemes are like the atoms of speech. We also said that this is not the best description, since atoms are not the smallest thing in the universe. According to the standard model of physics, there are things which are much more fundamental than atoms. We are representing something different with 1 through 9, something much more basic. If we combine the phonemes, we can arrive at morphemes. These are similar to phonemes in that they are small units which cannot be further subdivided. They are different in that they must also have a meaning associated with them. Said another way, morphemes are the basic building blocks of meaning, something which is fundamentally different than just a group of distinct sounds. In a spoken language, not every sound has a meaning, but every meaning has a sound. Every complex number is a combination of our mathematical phonemes. They each have a most basic meaning associated with them. 1 plus 9i is not 2 plus 9i. They mean different things despite using the same phoneme next to the I. This is where this theory goes from good to great. I also believe this is the key to validating the model. Morphemes represent sound with meaning. This means if we take the complex numbers in this model, we can assign a sound and a meaning to them. In other words, this model is convertible into waves, since sound travels in waves. If you wish to explore how I suggest assigning the complex numbers to the fundamental particles, I encourage you to watch my video, The Creation Code. For now, we will simply say that the complex numbers are the morphemes, the fundamental particles, or sounds with meaning. Once we have our morphemes, we can arrange them into a syntax, or a sequential order. The grammar is what proves the syntax is correct, and ultimately, the pragmatics is what allows for the prediction of intent, or perhaps another way to say this is to validate the system as a whole and not just sequentially. This model is constructed in such a way that the patterns cross-validate each other systematically. In simpler terms, we can verify a number's position by checking it against multiple patterns from multiple directions. If the truth is what we seek, then we should find it to be self-evident from many different angles. It is my hope that this model is one day upheld as a unified field theory, and that those who build technologies from it will do so with the truth as the cornerstone of their machines. Thanks for watching. If this kind of math interests you, I encourage you to subscribe or comment below. For more information about me and my work, you can check out my website, which is in the description box.